Trade discounts, cash discounts, markup, all good stuff, and markdown. Welcome to Unit 4. Unit 4 will be split into 3 components just so I don't kill you with long videos. So we got some objectives here. So we're going to solve problems using trade discounts. Trade discounts are applied in a variety of situations, which we'll talk about in a little bit. Sometimes some companies will offer a series of trade discounts, and then other companies will offer just one big trade discount. And we want to be able to compare those 2 deals. And so that's where calculating equivalent rate, single rates of a discount for a discount series. We'll apply methods of cash discount. So for instance, sometimes you get a cash discount for paying within a certain period of time. We'll solve problems involving markup based on either their cost or their selling price. We'll also solve problems involving markdown, for stock that's become dated or once we need to liquidate it. And then probably the most important section, the last section, and we'll solve integrated problems involving discounts, markups, and markdowns, right? More like the real world, where you have a series of these things all happening at once. They're just not one little isolated one-offs. Okay, so this is a highly stylized supply chain, and in the modern era, there's not as many channels to a supply chain as there is represented here. But this is just to represent all the possibilities in one, chain, okay? So we have a manufacturer, it goes to the distributor, it goes to the wholesaler, it goes to the retailer, it goes to the customer or the consumer. A lot of times, some of those channels are not there. So maybe there's a distributor but no wholesale. Maybe it's right from the manufacturer to a distributor to the consumer, right? It's hard to say, right? But just to give us a sense that there is a supply chain, to justify the existence of each one of these channels, they have to bring some value added. If they're not bringing any value added, often over time you see them removed from the supply chain. Usually painfully, bankruptcies, lawyers, and courts, and all that kind of nasty stuff. Okay, so but anyway, this is sort of a highly stylized sequence that goes through. This is kind of like I'm hungry. I'm doing this at 10:20. I'm sorry, starting to think of lunch, and we start to think of all the things that go into providing product at a restaurant. Right? You start off, there's seeds, there's fertilizers, there's pesticides, all sorts of controversy even in that supply chain, right? Then things are cultivated, things are grown, whether it's a fruit and vegetable farm, a dairy farm, and then those things go to get processed, the butchers and people who are agricultural workers who pick the fruit and the veggies and then freight, whether it's by truck for most part, train, even boat, but mostly by truck. And then it goes to the variety of other segments, right? Whether it's a deli, whether it's a grocery store. And then ultimately all those kind of components make their way to a restaurant, right? Not to ignore the cotton farm, the processing, the freight, the linen store, the table linen, so that we have a nice clean, or used to, right? This is, again, I've taped this in the COVID era. The table linen is out, and we're mostly dealing with tables that have been the heck sanitized out of them. Hey, so and they all go to the restaurant. So we see lots of elements in the supply chain here. Each one of these channels brings some value added, and then they culminate in the restaurant. Right? So the supply chain can be quite complicated. One year I did a supply chain for some oil and petroleum products, and it was like all over the place. It was a crazy supply chain. So like I said before, there's the highly stylized supply chain that we saw in that first graph. Some components may be there, some components may not be there. It's probably fairly rare that every one of those 5 channels exists. Nevertheless, for each one of those channels, whether it's a manufacturer, wholesaler, retail, they do have to make money, right? And so they take the price that they pay to whoever's further up in the supply chain, add their value added, mark up that price, sell it to their customer. Okay. So the idea here is we sort of starting to talk about some of the relationships that exist. Okay. For most things that we'll deal with in this course, you don't want to, there is a nice little mathematical toolbox that goes with this unit, and it's on the last couple of slides, and that's probably a very useful thing to have handy or printed off when you do questions of this nature, when you do the exam questions of this nature, and so on. Okay. So the last couple of slides, there's our math toolbox. But we want to talk about sort of how those relationships came about. So we're not just trying to memorize formulas out of the sky. I've tried to do that. It's hard. It's hard. There's tears, there's frustration, and there's typically a lack of success. Okay. So when we have manufacturing costs, they have to mark it up. So they take their list price, and then they apply the discounts. Right, so the wholesaler gets some sort of discount. So the manufacturer's got their costs, they add their markup, however they do that, we'll talk about that later. And then so they have some list price, and then there's discounts, right? So not everybody gets the same discount. Right? Bigger customers may get a bigger discount than smaller customers. Customers who participate in certain programs may get a discount. Those who don't participate in the program don't get the discount. And so after you take that list price, you take off all the discounts, you get the price that the wholesaler actually pays. Makes sense, right? Wholesaler takes that price, marks it up, however they do it, and now they have a list price, and now they have trade discounts that they make available to the retailer. Whatever those trade discounts can be, paying early again, participating in certain promotions and so on, buying certain quantities. And then the retailer takes their cost, that net price. That net price is what the retailer actually pays, right? So to the retailer, that is their cost. They take the cost, apply a markup. They have their regular selling price. They try to sell it as much as they can at that regular selling price. Things happen, though. Perhaps you don't sell as much as you thought you were going to. Sales just naturally follow a probability distribution. So sales could be higher than you expected, and then there is no markdowns. Sales could be lower than expected, and now you have some excess inventory, and you have to get rid of that excess inventory to make way for new models or new inventory. So hence the markdown. So you have then the sale or discounted price to the consumer. But it's kind of, that markdown is really like a trade discount to the consumer. Conceptually, it works the same way. Mathematically, it works the same way as well. Just slightly different terminology. That is it. So that selling price has got three components to it. And we want to make sure we cover all three components. And I was at a wastewater convention in Indianapolis, Indiana. Indianapolis, a wonderful town, one of my favorite towns. Great football stadium, super duper NFL football fans. And I went to one of the finance seminars that they have, and they're really focusing in on this idea that the selling price really has to cover the direct costs. Now, everybody there intuitively understood that, but it was really surprising that the expenses, the indirect costs, were often forgotten in pricing. And they really had to try to emphasize these folks. And these folks, these aren't small businesses and really teeny tiny businesses. They're more the larger small business or medium-sized business. I mean, they have millions of dollars worth of assets, and they're going, holy cow, I mean, I'm not really pricing in those indirect expenses into my selling price, because they're what questions that come up is, I seem to be have a good selling price, I have a lot of business, but profits aren't meeting my expectations. I feel I should be making more than I am. And so there was a big discussion over just those indirect expenses and making sure that you're allocating them properly. We're going to kind of take it as a little bit of a given, but when you run into that managerial accounting class where they start talking about indirect expenses and overhead and so on. Pay particular attention because making mistakes there can be pretty nasty for your bottom line. And then last but not least, my favorite little part, because it's got the happy face, the profit, the amount we actually get to keep, right? All the other money is going off to somebody else, right? So we got to cover all three components. If we fail to cover this profit, we won't go bankrupt right away, but eventually we'll go bankrupt, right? And shareholders, investors are not going to be happy if you don't produce any profit. Like, what's their return here? And eventually they'll abandon you, or they won't refinance you or provide more financing. And then if you don't cover these overhead expenses, you'll go bankrupt. A little faster than if you don't have a profit, but eventually you will, because those overhead costs have to be paid, and the cash has got to come from somewhere. And then if you don't pay your direct costs, you pretty much go bankrupt really quickly. So it's just a matter of how fast you go bankrupt if you're not covering all three of these components. So we've got our sales price, and we know when we're going to calculate it. We sort of know I got direct costs, indirect costs, and I got to make a little bit of money. Right? So when I think of the formula for selling price, it's going to have those three components in it. A trade discount, now that's just like it says, we know the word discount, it means you're getting a reduction. Why you get a reduction could be a variety of reasons. Okay, could be that you're buying last year's models. It could be you're meeting a certain quantity discount. It could mean that you're participating in a promotion. It could mean a customer loyalty for being with this customer for a certain period of time. Could be because you've reached a certain yearly or annual sales level. Variety of reasons. Okay. Also, one of the reasons is it can communicate a change in price. It can make a splash. If you look at retailing, and I've done a bit of retailing, you're trying to make a statement. And so you have that discount, 30% off, 25% off, 40% off, right? Tells the customer that something special has happened to this item. You want to get rid of it. We're pricing it to go, and it sort of makes you look at that item where you didn't look at it before. You look at regular price. Okay, yeah, fine. Maybe I buy that. Maybe I don't. And then you go, whoa, this is discounted. And then you go, okay, maybe I'll take another look at this, right? So it signals that that item that maybe you didn't consider when it was at full price. Now it says, hey, we've changed some stuff. Price has gone down. Take a look. And you get a second look at it. Now, maybe you buy the item, maybe you don't. But typically, we all kind of, the demand curves that we sort of learn in Econ 101, they sort of do apply. So we got our trade discounts. Now here we have our formula. I know the formula's on the left, and I don't want to rush into formulas too much. I like to talk about concepts a little bit more. So the amount of our discount is we apply the rate and we multiply it by the list price. Right? Stuff we were talking about chapter 3 and you saw in high school and whatnot. Okay? And we calculate discounts all the time. We go to stores, we go online, we're looking at how much is this discounted relative to that. And we do these comparisons anyway. All we're now is just applying maybe a little bit more businessy and terminology context to a problem you've been solving for quite a while. So the amount of discount, apply the rate, times by list price. That's the dollar amount here. So we're talking dollar amount. Note the difference between amount of discount and rate of discount. Rate of discount is going to be a proportion of some sort. That list price is just now, we're just rearranging this. It's just how much that discount was, and you divide it by the rate of the discount. So really stuff we were reviewing in the ratios, proportions, and percents unit. Nothing new there, just a new context to that Unit 3 information. Same thing with just rearranging the formulas. And the big one here is we think of what price do I actually pay? At the end of all this, you're going, okay, got discounts, got that. Well, what the hell do you want me to pay? And so that thing that you want to pay, that's the net price. So we take that list price, and we subtract the discount off. And you're going, well, duh, I've been doing that. I mean, makes obvious sense, right? So, and it does make obvious sense. So we don't need to make it feel complicated because all of a sudden we're talking about it in a university course. Okay? So that what price you actually pay, you take the original price, apply the discount. So dollar amount is the net price, dollar amount is the list price, dollar amount is the amount of the discount. So those are all dollars. Now, as we saw before, how do I find the discount? Well, it was the very, very first slide, right? So you could probably guess that when we look at the formula for the net price, I'm going to have a net price. That's just an amount. A list price, that's just whatever's on the list. That's kind of a given, right? So we've got a fancy word for list price. We call it exogenous, determined outside of all this. And then the amount of the discount. There's going to be a further calculation to that. So when you kind of go through all that, blah, 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 and you get this nice little formula on the bottom, which just brings that amount of discount calculation, pulls it into that equation or relationship for net price, brings it all together, cleans up the math so it's a nice sleek formula. And so that's the most important formula there. The net price N is just the list price, and then in brackets 1 minus the discount. That's the key thing. But conceptually, it's just this net price equals list price minus the amount of discount with the equation for the amount of discount pulled into this relationship. Okay. So sometimes you can somebody your vendor will offer more than one discount, right? So that formula is great for one discount, but what if there's a couple of different discounts available? You get a discount for paying a little bit early, you get a discount for buying a certain quantity, you get a discount for participating in a certain promotion, you get a discount because you bought, well, I was going to say because you bought some of other product, but some locales don't let you do that. It's called tying, and it may be illegal in some jurisdictions, but not all. But there's a whole variety of reasons why you offer a discount. Okay? So you get a couple of discounts, 2 or more, and now you got to think, well, okay, I still got to calculate my net price. I still got to work all these discounts in there, because at the end of the day, I got to figure out what did I actually pay for this doggone thing, right? So now there's a, the textbooks will show you how this all comes about, and I'll leave it to whatever textbook you want to look at to come up with that. But essentially, that net price is just start off with the list price, right? No matter 1, 2, 6 million discounts, we always start with the list price, and then we apply the discount, and we get an initial net price, and then we apply another discount, and we get another initial net price. Then we keep applying a series of discounts. Okay, so we apply those series of discounts. Be very careful. Don't add up all the discounts and subtract it by 1 and go that way. That would be easy. It would also be so seriously wrong. Okay, so we have these series of discounts. So very similar to the original formula, just a kind of a more terms for those discounts. So we have that. But what's also important is, okay, we got the vendor who offers us the multiple discounts, but we may have the vendor who offers us only one discount. Or we could have the situation where a vendor offers 3 different discounts. This other vendor offers 2 different discounts. We got to be able to compare these things to each other. So we could come up with a single equivalent rate so that I can compare everybody, right? It's kind of the one rate that binds them all, Lord of the Rings kind of thing. So we have a calculation for that, and so we can note the square brackets here. Note the square brackets, very important. So we go 1 minus each, within brackets, each respective discount, multiply them all together within the square brackets, and then subtract that number from 1, and that gives you the single equivalent discount rate. And that allows us now to compare across all vendors. Ones that offer 1 discount, those that offer 2, those that offer 3, those that offer 4, and so on. So very useful formula there, right? Because we want to make sure we're getting the best deal. Very important. Okay, so we're going to do some questions here, and we'll work through that, and that'll end this little. Our friends at Golf World sell a set of golf clubs for $762.50 below the suggested retail price. That has given us a clue that the amount of the discount is $762.50. Gulf Oil claims that this represents a 62.5% discount. So D, my discount rate, expressed as a proportion. So I'm going to use this in a mathematical equation. Okay. What is the suggested retail price? Another word for saying what's the list price. So list price, that's what I want. Okay. So intuitively, I know when I'm thinking, I'm calculating the amount of that discount. I know that is the discount rate applied to the list price. Right? So intuitively, I didn't even have to look at a formula sheet for this. I just had, hey, how do I calculate discounts? Okay. And from there, I just start plugging stuff in, right? Rate of discounts, and then I got this L. Hey, now I'm right back into Unit 1, Unit 2 land here. I'm going to isolate L by dividing both sides by 0.625, and I get an L of $1,220. Okay. So simple, right? Right, just applying stuff. We've got a little bit of context. Just using some new terms. Moving on. Mobile phone listed for $174 less 16 2/3% discount. So sorry about that. That looks a little bit hard to read. PowerPoint, not the greatest with formulas, or maybe I'm just not the greatest with PowerPoint. So we got a list price of $174. Got 3 different discounts there. Right? So we kind of reaching into our toolbox, and we do have a formula for net price in that case, and that is the list price minus one in brackets 1 minus the first discount, multiplied by 1 minus the second discount, again in brackets, and then in brackets one last time 1 minus the third discount. Right? So I have something for this, right? And it works. So now it's asking me for the net price, so I just continue on with the N. I do have a list price of 174. 1 minus, I'm just going to go to 4 decimal spots here. If you're doing this on My Math Lab or other online assignments, 6 decimal spots is usually what they recommend. Okay. And then 1 minus 0.10, and then 1 minus 0.08. Okay. Remember, our good old friend BEDMAS, do all the operations in the brackets first, then we'll multiply everything together to get the net price. And when you do that, you get about $120.06 or $120.055. Okay. And there's part A done. Okay. Now we move on to part B. What is the total amount of discount allowed? Keyword, amount of discount. That amount of discount means I am talking about a dollar value. How do I find discount? Well, if I just think of this intuitively, right? That discount is A. Now, I could apply a discount to a list price, but I don't really have a single discount here yet, so that seems complicated. But what is the amount of discount? Well, I take my original price, right, and I subtract from it my net price. The difference between the two must be the amount of the discount. What the heck else happened there, right? So I look and go A, and I had that list price of $174 minus the net price, which I just calculated, and this just becomes simple subtraction. Right? I am done. Right? Little shade under $54. Right? And just because I sort of got the relationships, wasn't fumbling for formulas all the time, understood the key relationships, and then the problem just kind of flows naturally from there. Okay. C, what is the single rate of discount allowed? Important, right? One of the things we just talked about. We kind of look at, hey, I got a formula for that, right? Right? Oh, there we go, right? Well, single rate of formula allowed. I've got that formula right there at the bottom of that slide. Pull that formula out of my mathematical toolbox, and I apply it in this particular context. So what's that single rate? Equals to 1 minus, and then I got the big square brackets, 1 minus the first discount in brackets, round brackets, 1 minus the second discount in round brackets, 1 minus the third discount in round brackets, and then seal it all up with a square bracket. Okay, so again, bad maths, do the stuff in the round brackets first, multiply them all together within the big brackets, and then subtract it from 1. So I get 1 minus 0.68999724, and that's 0.3100276, or about 31%. Right? And we're all set. And we got one last question to round this all out. We have office desk listed at $440, less a couple of discounts. Is offered at a further reduced price, so it's got a third discount in there, of $274.89. A couple of different ways you can work on this. You could work through it as multiple discounts, where you're solving for the third discount, and use that formula. Or you could find the net price using the two discounts you did have, and then find the single rate discount that's further applied. Get you to the both places. I'm just going to do the second version, only because it's just maybe a little easier, and it gives us a little bit more practice in finding discounts. Okay, so my net price, the first one, so I call it a little subscript N1 in BATS, it's the first one. And so I have my list price of $440, apply the two discounts of 25% and 15%, and I get a net discount, first one, of $280.50. Okay, so now I'm going to reduce that $280.50 by a discount rate to get to $274.89. So that net price really now becomes the list price for the second equation. And the answer that I'm looking for will be the net price, the second one, right, which is equal to that $274.89, which then equals to our new list price, which is the old net price, $280.50, and then 1 minus D. Okay. I got that 1 minus D sitting sort of nasty in brackets and things like that. So I want to isolate it. It's a little bit trickier. I'm going to get rid of the $280.50 first off. Because you could multiply it in and do a lot of extra other work, but that just seems like a whole lot of extra other work. And so now I have 0.98. Oh, sorry. So now I do have 0.98 equals to 1 minus D. I'll pull the 0.098 over to the right-hand side, and its sign will change. And then I'll pull the D over to the left-hand side. Its negative sign will change to a positive, and I get a D of 0.02, or about 2%. Okay. And that concludes this lovely little unit.